Okay, now to find trig functions of real numbers. So evaluating a trig functions of any angle. All right, so to find the value of trig function of any angle theta, we're going to determine the function value for the associated reference angle, and depending on the quadrant in which the angle lies, affix the appropriate sign to the function value. I do this a little backwards. I actually decide what quadrant this angle is going to be in, and is it going to be positive or negative in that quadrant, and then I go through and find my reference angle, and I use those to actually be able to tell me the value. So let's try this. All right, so in example 5, we're going to use reference angles to evaluate. So sine of 5 pi over 3. Now I know 5 pi over 3 is on your unit circle, so you can look at it, use your ordered pair, and boom, you're done. But let's go ahead and let's work this out the way we're going to work out some of the others that aren't quite so easy for us to do. So first thing, 5 pi over 3. I need to find out what quadrant that's going to be in. So you can convert it to degrees if you need to, but you'll find that this is going to be then in quadrant 4. And in quadrant 4, what do we know about sine? Well, again, let me draw this. All students take calculus. In quadrant 4, only cosine and its reciprocal are going to be positive. So that means that sine is negative. So I can say, well, this is equal to the negative sine of, and right here, I'm going to put that reference angle. Well, how do I find the reference angle? If it's in quadrant 4, remember the reference angle is going to be equal to 2 pi minus our angle. So get that common denominator. Which is pi over 3. So I'm going to plug that in right there. So I'm looking for negative sine of pi over 3. Well, so I know it's going to be negative. And now we'll let you use your unit circle, or you could use your triangles if you needed to. What is sine of pi over 3? And we look it up, and we can see that sine of pi over 3 is the square root of 3 over 2, I believe. And this tells me it's negative, so I end up with a negative square root of 3 over 2. All right, cosine of negative 60 degrees for B. Well, where is negative 60 degrees? Well, negative 60 degrees has to be in quadrant 4 because it's going down 60 degrees. And so what do we know about cosine in quadrant 4? Well, we know that cosine is positive. So that means that I'm looking for the positive cosine of the reference angle for negative 60 degrees. Well, first thing, negative 60 degrees, I don't really know a lot about my negative angles. So we can always find that coterminal angle by adding a complete circle. I should put a theta, I should put angle. All right, so you can take negative 60 plus 360, which tells me it's the same as 300 degrees. So I could go ahead and put 300 degrees there. Now let's go find that reference angle. So the positive cosine of, and this is where I'm going to put that reference angle. Well, in quadrant 4, remember, your reference angle is 360 minus your angle. So we find our reference angle is 60 degrees. Is that a coincidence that it was 60 degrees and we had a negative 60 degrees? No. It'll work like that every time as long as it's somewhere between 0 and 90. Or in this case, somewhere between 0 and negative 90 degrees. It'll always be the same. All right, so we've got, if we're looking for positive cosine of 60 degrees, so we know it's going to be a positive. Look on your unit circle. You can either or use your triangle at 60 degrees. What is that cosine value? And I believe you find that it is the square root of 3 over 2. And so it's going to be positive square root of 3 over 2. You don't necessarily have to put the positive symbol. If you don't put a negative, that means it's automatically positive, just like always. But I did that so you'll know that, hey, I did not forget to check my sign, the SIGN of this answer. All right, and then finally, example, our letter C, 17 pi over 6. That's a really big number. So you can convert that in your calculator, and let's see, what do we get there? Okay, well, that was a really big number, so I'm just going to use coterminal angles to help me find where this is at. So let's see, if I take 17 pi over 6 and I subtract 2 pi, 17 pi over 6, I should have changed colors because I'm a different example. Minus, what is that, 12 pi over 6? Still, that gives me 5 pi over 6, which is in quadrant 2. All right, so we know this is in quadrant 2. And so because we know the 17 pi over 6 and 5 pi over 6 are coterminal, we could say this is equivalent to tangent of 5 pi over 6. Well, we're in quadrant 2, so we need to find that reference angle. Let me draw a line here in between these of a different color to help separate this problem, because I forgot to change colors of the pen before I continued on. All right, maybe that'll help. All right, so quadrant 2, remember our reference angle. Oops, first, what is tangent in quadrant 2? Is tangent positive or negative? Well, let's see, looking up there at the top in quadrant 2, I see that sine and its reciprocal are positive, which means tangent must be negative. Now back to finding that reference angle in quadrant 2. It tells me you're going to take pi minus your angle. So find that common denominator. And so we find our reference angle is pi over 6. So I know that this is equivalent to the negative tangent of pi over 6. All right, so I've got the negative. Tangent's one of those I have to work out. Tangent is y over x. So negative, excuse me. So let's look and see on pi over 6, or on pi over 6, what is y? Okay, looking at my unit circle, I see that the y value is, hold on, I'm looking at the wrong one. 1 second here, guys. Okay, so we see that y is going to be 1/2. X is the square root of 3 over 2. Remember, can't have fraction within fraction, so keep it, change it, flip it. So you get 1/2 times 2 over square root of 3. Your 2's are going to cancel, so you get 1 over the square root of 3. Can't have that radical on bottom, so multiply top and bottom by the square root of 3, and so we get square root of 3 over 3. But what did I do wrong? When I started my keep it, change it, flip it, I forgot my negative. So we need to bring that negative right along with it each step. And so we end up with our final answer is the negative square root of 3 over 3.